Well, welcome to my channel today. Physics. My name is Ihaji. Today I'm so privileged to take you through relativity. And by definition, relativity is an aspect in physics that deals with how things relate to each other in terms of space, time, and where they are positioned, and of course relativity to each other. Well, there are two theories that tend to describe what relativity is, and one of them being general theorem of relativity. Well, general theorem of relativity says that gravity is a manifestation of curvature in space-time. Secondly, there is a special theorem of relativity. Special theorem of relativity says that it describes that is a theory that describes the relationship between space and time, and that the physical features which stipulates that I would say physical features which is stipulates that the experimental values ought to be the same in all frames of reference. Well, frames of reference is actually the coordinate system which act as point of reference to a certain concept in physics. Well, there are postulates under which makes this kind of a theory to be effective. Postulate number one say that all laws in physics are of the same in all frames of reference, moving at a constant velocity relative to each other. Postulate number two states that that the velocity or rather speed of sound of light has the same value in all initial observers. Well, going to illustrations, this illustration gives to try to explain what this kind of a theorem that tends to explain what relativity is as far as a concept in physics are concerned. Illustration, for example, if I have a watch that is at hand, which is moving at a certain velocity, then the other one is at rest in the lab. So considering that watch which is at rest, the time between ticks is known as proper time, which is denoted by TO. So this proper time is actually the time which a particular object is at rest. Okay, then go to, for example, if I take two mirrors perpendicular to each other, so that the other one is here and the other one is here. Let's say this watch is, let's say a certain watch is here, watch at rest. This is an observer moving this direction, right? So this one is one mirror, second mirror. So the time taken for a light to travel from one mirror to the next time is given by t over 2. Okay, then the length from here to here is known as proper length, which is denoted by LO. So this is the length from here to here. Then this length is also, can get this length from the observer towards this one and this one. So this one is a point of reference. Okay, therefore the distance between here and here is given by velocity times time, because this watch is moving at a certain velocity, moving towards this mirror. Therefore we can compute such that the speed of light in air is given by c, which is equal to distance over time. Okay, but remember time is given by t over 2, such that t is the time taken for light to travel from one mirror to another. Therefore we can conclude that c is the same as 2LO, which is d is the same as LO over t. Therefore this distance can be given as what? Therefore t so that's it. So distance over time is equivalent to that. So we can actually draw some kind of a triangle, so that this way should be this way. So whereby this first mirror, this second mirror, this one point of reference. So this one is VT. This one is actually this one is LO. Okay, so this one is given by as C TO over 2. So velocity times time, we get distance. Okay, fine. You can use theorem of Pythagoras to compute this. You can say that CT over 2 squared is equal to VT this is over 2 squared plus LO squared. Okay, therefore we can take this one to the other side, we remain with this one. Okay, so that LO squared is equal to, remember this one is the length between two mirrors, is equal to CT over 2 squared plus VT over 2 squared. So you can put in this side, say T, put T as a subject, T over 4. Remember this one is whole. Remember this one is whole or squared. So T over 4 is equal to no, it will be T over 4. Okay, into C. Actually, should it minus or minus? Should be actually be minus, because we're moving from here. This one is minus, so minus V. remember this is v squared c squared. Okay, v squared is equal to, this is the same as LO squared. Therefore we can say t over 4 into c squared minus v squared is equal to LO squared. Okay, so this one 4 we can put it here over 4, this one cancel, so it remains the t is equal to, remember this one is t squared, remember this is t squared, is equal to LO squared over, actually this one should be 4 LO, then c squared over v squared. So therefore we can generally conclude that t squared is equal to 4L squared over c squared over v squared. Now this t squared represent time dilation. Now in definition, time dilation refers to the difference of elapsed time measured by two observers due to velocity difference relative to each other, or differently situated relative to the gravity. So taking this kind of equation such that t squared is equal to 4L squared, this is proper length, c squared over v squared, we can actually easily compute this. We can say that we can put c as a subject here such that t squared is equal to c squared over 4L squared, such that it will be 1 minus v squared over c squared. So when you multiply this one, it will be c, then if c it will cancel that way. Well, this one you can put it here, where t squared is equal to 4LO squared over c squared over 1 minus v squared over z squared. Now if you have to understand that TO is the same as 2LO over C. This one is what we call time at rest. Okay, time at rest is equivalent to this, so we can actually compute this one. So this one will be T squared is equal to TO squared over 1 minus V squared over C squared. Now let's get the square root on both sides, square root and square root on both sides. So in this one you actually say that T is equal to T over 1 minus V squared over Z squared. All right, so this is what we called time dilation. This time dilation, this time at rest, this one. Now this one forms an expression for relativity such that time dilation is given as that one. So but something that you should note that V squared over C squared should be less than or equal to 1, because normally C is greater than velocity, therefore V squared is greater than is less than or equal to 1. So this one forms first over time dilation is equal to T, which is T time at rest, over square root of 1 minus V over squared. Okay, thank you very much. Please like and share my video. Thank you.